Hello guys, in this example we're going to take a look at computing directional derivative to a function this time of 3 variables, and they give you a point. So this is x, y, z. The point they give you has coordinates 9, 1, 1, and then they give you the direction vector, and that is given by -8, 1, -1. Okay, so what are the steps? Step number 1, let's find the gradient. So what's the gradient? Gradient of f. Now, think about taking the derivative of x, y, z, which are multiplied, with respect to x. So when you're taking the derivative with respect to x, the other variables are considered like numbers, so they're constants, okay? So we treat them as like number x, so like yzx, and derivative of a number x is just the number. So derivative with respect to x will just be yz. Now, similarly, if you are taking the derivative with respect to y, then x and z are numbers, and so it'll be like number y, so that number will be xz. Finally, you'll probably already understand that derivative with respect to z would be x times y. So this is what the gradient is, and it's a vector. All right, so let's just plug that in here and see. Okay, so that it checks it for us. All right, so that's correct. Next thing that they want is find the direction vector. So you may be asking, well, you just gave me the vector, that's the direction vector, -8, 1, -1, and so that's it, right? Well, no, that's not it, because the direction vector, the requirement on it, and that's just based on the definition of the directional derivative, is that the direction vector must have unit length. So how do we make a vector have a unit length? In other words, a length of 1. What we do is we take the magnitude of the vector, and that is square root, and then we take each component and square it. Now, I always recommend, if the components are negative, not to put the negative, because you're going to get confused whether you should use parentheses or not, which actually you should. So I would just go ahead and skip them, because the answer is the same when you square the numbers. So this will be 64 plus 2, so that's 66. So that's your magnitude. And then to find a vector in the same direction as v, I will call it v with the hat, you're just going to divide the components of v by the magnitude. So this is what you get, okay? And then you got -1 over square root of 66. Okay, so that's what will happen here. Okay, so -8 over square root of 66, 1 over square root of 66, and -1 over square root of 66. If you don't insist that the vector has a unit length, then you can always multiply by any number and you will get a vector in the same direction. So then directional derivative will be meaningless, because it could be any number. And finally, the directional derivative is going to be the dot product of the gradient and the direction vector. However, directional derivative should be a number at a specific point. So we're not done with that. So we were supposed to find the gradient, and we were supposed to plug in the point that they gave us, because we're not doing it anywhere. We're doing it at this specific point. So I need to plug in 9, 1, 1 into the gradient right here, which is pretty easy. So x is 9 and y and z are 1. So this will be 1, this will be 9, and then this will be 9. Okay, and so after I do that, I'm going to take the dot product of this, so directional derivative in the direction of u, which is v hat, at the point 9, 1, 1, is going to be the dot product of these two vectors. Now, be careful with the dot product. Never make it a vector. It's not a vector. You just multiply the components and add up the results. So you got 9 over square root of 66 and minus 9 over square root of 66. No IJKs here. Directional derivative is a number. Now, because all of them have the same denominator, square root of 66, we should really for sure simplify this. So -8 plus 9 is 1, minus 9, that's I think -8. So looks like directional derivative in this case is negative. So this is negative, which could happen. Directional derivative could be any number.